Hello viewers, I'm Kausalya. Today we are going to solve problems related with delta connected loads. The problem is determine the line currents for the unbalanced delta connected load of figure given. Assume the phase sequence to be RYB and the value of E is 200 volts. So here what do you mean by an unbalanced delta connected load? Here, that is a balanced delta connected load is one whose impedance value in all the three branches will be the same, right? Whereas an unbalanced load is one where the impedance value is totally different from each other. For example, you see for this branch, the impedance is 30 plus J40. Whereas here it is 8 minus J4 and here it is 15 plus J12, right? Now the next thing is the value of E is given as 200 volt. So here we are going to, that is here the value of line voltage and phase voltage, everything is same, right? Because this is a delta connected load. So here by ourselves we are taking ERY as reference, right? Therefore ERY is equal to 200 with an angle of 0 degrees. And the next one is EYB, which is 200 with an angle of minus 120. And finally EBR is 200 with an angle of plus 120. Right. Next we are going to find the value of currents. So here we are assuming current by ourselves. Let I1 is the current flowing through this path and I2 is the current flowing here and I3 is the current flowing here. So how to find the value of I1? I1 is nothing but the respective voltage, right? Voltage divided by this impedance. Therefore, here I1 is nothing but ERY divided by the respective impedance is 30 plus J40. So here just substitute the values. Here this rectangular form is converted into polar form, right? And finally here this is your answer. This is your answer in rectangular form. Right, these calculations you can do easily with the help of a calculator. And again it is up to you. You can directly substitute and find the values. Right. And here the next thing is the value of I2. So how to find the value of I2? You see again I2 is the current flowing through this path. So what is the voltage? Here EYB should be taken into account. Therefore EYB divided by 8 minus J14. And again here just substitute the values and here the answer is 6.26 minus J 10.71 amps. And finally we are moving with I3. So I3 is nothing but EBR divided by that impedance. So again just substitute the values and here the answer is 1.58 plus J 10.3 amps. Right. So in this problem we have to find the line currents. So what are all the line currents? Line currents are nothing but IR, IY and IB. Right. So here the value of IR, IY and IB is calculated by using Kirchhoff's current law. Right. So here to find the value of IR you just consider this node. Right. When you consider this node, what are all the currents that approaches the node? IR and I3 are the current that approaches the node and I1 is the current that leaves the node. Right. Therefore, here we can write the current leaving the node is equal to the current approaching the node. Right. So here we can write it as I1 is equal to IR plus I3. Right. Similarly, how to write the value of IY? So when you look at this node, you see I2 is the current that moves away and I1 and IY are the currents that flow towards this node. Therefore, I2 is equal to I1 plus IY. Right. Again, consider this node. When you look at this node, you see here I2 is the current that flow towards, okay, I2 as well as IB. Here I3 moves away. Therefore, I3 is equal to I2 plus IB. Right. These are all the things which are written by using Kirchhoff's current law. Right. So these are all the value of, that is IR, IY and IB or the value of line currents which we need to find. Right. So here again you see IR plus I3 is equal to I1 and I need only IR. Therefore IR is equal to I1 minus I3. We know the values of I1 and I3, so just substitute and find the value of IR here. Right. Similarly, to find IY, Iy plus I1 is equal to I2. Therefore, Iy is written as I2 minus I1. So again, just substitute the values and here is your answer. It is 8.42 with an angle of minus 63.2 degrees. And finally, the value of IB is given as I3 minus I2. So again, just substitute the values and here finally the answer is 21.51 with an angle of 102.4 degree amps. Right. So these are all the values of line currents. Right. Here comes the end of this problem. We will proceed with the next one. The problem is a three-phase delta connected load has, you see these are all the different values of impedances. And this is connected to a balanced three-phase 400 volt supply. Find the line currents, right? IA, IB and IC. Assume the phase sequence as A, B and C. Right. So here this is a delta connected load and the value of A, B, B, C and CA are given. Right. So just accordingly, just draw the diagram and this is your A and this is your B and this is your C. And IA, IB and IC are the line currents. Right. So, okay, this is your diagram, right? IA, IB and IC are the line currents. And you see here, ZAB is 100 ohms, right? So, between A and B, I am having 100 ohms. And between B and C, it is minus J 100. And finally, between A and C, it is this value, right? This is your A and this is your C point, right? Now the next thing is again we have to take reference voltage. So here in this case you see again EAB is taken as reference voltage. Here the value of voltage is 400 volt. Therefore 400 with an angle of 0 degree. EBC is 400 with minus 120 and finally ECA is 400 with plus 120. Right. So these are all the different values of voltages. And here the next thing is IAB. Okay, IAB is the current that flows through this path. Right. This is your IAB. So here IAB is given by EAB divided by ZAB. So EAB is 400 with 0 degree and ZAB is 100. So here the answer is 4 amps. Right. Similarly IBC. So here IBC is nothing but, you see, between B and C. So this is the current. Okay, this is the value of current. So here this is your IBC. Right. So the value is given by EBC by ZBC. So EBC and ZBC is nothing but minus J100. So when you convert this in polar form, it is nothing but 100 with an angle of minus 90 degrees. Therefore, the value of IBC is 4 with an angle of minus 30. So here it is written as 3.46 minus J2 amps. Right. And finally, ICA. ICA is given by ECA by ZCA. So here the value of impedance is 70.7 plus J 70.7. So just substitute the values and here the value of ICA is given as 4 with an angle of 75 degree and in rectangular form it is 1.04 plus J 3.86. Right. Now we are going to find the value of line currents IA, IB and IC. So here again the same thing we are going to apply Kirchhoff's current law. So when you apply Kirchhoff's current law, it is clear, right? You see here IA is the current that flows towards the junction, right? And similarly ICA is also flowing towards this junction and IAB is the current that moves away. Therefore ICA plus IA is equal to IAB. But what we need actually, I need IA. So IA equal to IAB minus ICA. Just now we have calculated these values. So just substitute and find the answer. So here the answer is 4.86 with an angle of minus 52.5. Right. Now the next thing is IB plus, again we have to consider this node. Right. So when you consider this node, what happens? You see IAB and IB are the currents that flow towards this node and IBC is the current that flows away. So just equate. Finally IB is given by IBC minus IAB. Just substitute and this is your final answer. And the next thing is we have to consider our node C. So when you look at this node C, this is the current, okay? These two are the currents that flow towards this. So IBC plus IC is equal to ICA. So therefore here just again substitute the value and finally the answer is 6.34 with an angle of 112.44 degree amps. Right. So these are all the values of line currents for this given problem. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.